So today we're looking at solving systems by graphing. Just heads up, tomorrow we won't meet for class. We have an assembly tomorrow. I'm not sure, it's a speaker of some sort. You'll be dismissed during homeroom, and then we're not doing an assembly schedule. We're just skipping first period. So we won't see each other tomorrow. So your homework will be due on Wednesday then. Okay, my other class, we're just going to do some in-class practice since I won't be seeing you guys tomorrow. All right, so the first vocabulary word I already spelled out for us says a system of equations is a set of two or more equations that use the same variables. If the graph of each equation is in a system of two variables is a line, then it is a linear system. We will start looking at, later in the year, I guess, some quadratics and linears and kind of putting all those together. But there are actually three ways to solve a system of equations. The first one is what we're going to do today, which is graphing, where you'll graph each equation and you'll look where they intersect. We write the final answer as an ordered pair, and that's the solution to the system. There are two other ways that we'll learn algebraically. One of them is to solve by substitution. We'll look at that on Wednesday. And then also elimination, which is the one that we'll use a lot. Today we're just focusing on the first one, which is graphing. So one way to solve a system is to graph each equation separately, and then we're going to look for any common points. Common point on both lines. Again, that's going to be where they intersect. And then lastly, we'll write this point as an ordered pair. So the example over here that you can see with the two lines intersecting, you can see that the solution would be 1, 2. That would be the solution. So the solution of a system of linear equations is the ordered pair that makes both equations true at the same time. So that x value, when plugged into both, would get you that equivalent y value. And we will also use our graphing calculators today to have it actually calculate it for us too. So we'll do it by hand and with our graphing calculator today. So the easiest, or I should say, the times you will want to choose graphing are usually when they're already in slope-intercept form, because those are easy to graph. Okay, so these are both in slope-intercept form. So we're going to graph the first line. And I'll do this one in pink. We're going to start on our y-intercept, which is -3. And we're going to use our slope to find our other points. So our slope is 2, technically 2 over 1. So I'll go up 2 and over 1, up 2 and over 1. And for these ones, you do want to be careful that you draw your line straight, because if you don't and you kind of wing it, it might not cross at the exact point that it should. So just be really careful. Again, you might just want to put more points on the line, because I'm certainly like to look at where the points over cross out. Abby? Yeah, I do. Anyone else needs one? Thank you. So we're going to graph the second line. The second line has a y-intercept of -1 and a slope of 1, technically 1 over 1. So we'll start at -1. We're going to count up 1 and over 1. Again, be really careful. If you draw your line just like slightly off, you might think that's the intersection point. Up 1 and over 1, and you can see that this right here is where they cross. Okay, I am going to complete the graph though, but the solution is that point. So this is the solution where they cross. Who can identify that as an ordered pair? Garrett? 2, 1. Good, 2, 1. So that's the solution. Now what you can do is you can check to see if 2, 1 makes both equations true. So this again is our x and our y. So if I plug it into the first one, I'll get 1 equals 2 times 2 minus 3. You can just do it in your head. You don't have to show all of your work. 2 times 2 is 4. 4 minus 3 is 1. 1 equals 1. So that one checks. The next one, we would have 1 equals 2 minus 1. 1 equals 1. Check. I take the 2 seconds it takes you to check it, especially on a quiz or test, just to make sure if you somehow graphed a line wrong, you can catch your mistake. Now, not all of them will be that simple. Sometimes they're going to be in standard form. Now, after we look at our lesson on Wednesday, I would probably choose elimination to solve these because they're both in standard form. They're stacked on top of each other. Some of you might remember elimination where we get the variables to have a matching coefficient like these, and then we'll add or subtract downward. Okay, but today's goal is just graphing, so I want to show this one with graphing. And when they're not in slope-intercept form, you can graph using intercepts if you wanted to, plugging in 0 for x, plugging in 0 for y, find your intercepts and plot them. But most of you would probably prefer to solve for y for each one. So the first one I would subtract 2x on both sides to get y equals negative 2x plus 5. And the second equation I would need to add x to both sides. So now I have a system of equations that are both in slope-intercept form. From there, we would just go ahead and graph, starting at our y-intercept, using our slope. Now be careful, this is a negative 2 over positive 1, so we'll go down 2 and to the right 1. And then we'll also start at our y-intercept of 2 and count up 1 and over 1. You can see right away that that's where they cross. You are technically supposed to continue the graph if it says solve by graphing. So this is my answer, which would be 1, 1, 2, 3. I remember, I think it was on my midterm exam a couple years ago, I had an open-ended question like this, and it said solve the system by graphing, and a bunch of students graphed it and never wrote the solution. So make sure you realize that the graph is just there to help you find the answer. This is the answer, so don't forget to write it. And then, of course, if you do want to check this one, I would always check it in the original, just in case you made a mistake algebraically. So we'd have 2 times 1 plus 3. 2 plus 3 is 5. That works. Negative 1 plus 3 is 2. That works. So just plug it in kind of real quick and check. All right, the next one and last one on the front we have is our real-world example. So we'll have to write a system of equations first and then graph it. So this one says your New Year's resolution is to get fit. You plan to start taking yoga class at a nearby studio. Non-members pay $2 per class. Members pay a $5 fee plus only $1 per class. Define variables and write a system of equations to model the scenario and then solve by graphing. Okay, would you guys have a graph that is just the first quadrant, right? So it looks a little different than mine, and that's okay. So first of all, let's define our variables. Remember, x is your independent variable, y is your dependent variable. So what would I let my variables be in this problem? Abby?
X would be the amount of classes.
Good, the amount of classes. And what would y be? What would y be? Sam? Yeah. I'm going to say total cost because you might not be a member because that one person, the one scenario is a non-member. So I would just say the total cost to attend classes. So who can write one of the equations for us in the system? Abby?
Y equals 2x.
Yes, y equals 2x. That's for our non-members. And how about for the members? Ashley?
Y equals x plus 5.
Good. $1 per class is like 1x plus 5. And again, yours is going to look a little bit different than mine because your graph just has the first quadrant. So let me just see if I can let me just wipe this part out. All right, so you guys will want to, we can obviously just count by ones. We don't have to get crazy with this. But you would want to label your axes. So x-axis would be the number of classes. And our y-axis would be our total cost. And then from here, you're going to graph each line. So the first one, we're going to start at our y-intercept of 0 and count up to and over 1. And this one will look more like a ray because you can't have a negative number of classes. And the next one we would start at 5 on our y-axis. We'll go up 1 and over 1. And we should see that they cross. Oops. Right there. Who can identify that as an ordered pair for me? The solution. Clayton? 5, 10. Now, a lot of times they'll ask you then, what does the solution represent? So the solution represents that when you take 5 yoga classes, the cost is the same for members and non-members, $10. Sometimes they'll ask an extension question, especially the Keystone left questions with systems, if you guys remember. They would say, if you plan on taking 12 classes, would it be wise for you to be a member or a non-member? So if we plan on taking 12 classes each month, would it be better to be a member or a non-member? Abby? A member, because you can see that the membership one is going to increase slower than the non-membership. Now they might say if you're planning on only taking 4 classes, which is the better option? So if you're only going to take 4 classes, it'd be cheaper to not be a member because you're going to pay $1 less. Okay. Sometimes you'll see those extension questions. All right, now let's do our graphing calculator. And actually, I want to go back and do one of the ones we already did. Let's do example 1 on the graphing calculator. And then we'll do the other one too, just to give us some extra practice. Now the steps to do this are all typed out in that box in your notes. Okay, you'll see that the directions on the box in your notes say to solve each equation for x. Okay, or excuse me, solve each equation for y. And that's because your graphing calculator, you'll see there's the y equals button. You can only graph things that are in the form y equals. All right. So I just want to go back and graph example 1 first, just to show one more example. So press your y equals button at the top and clear out anything that you have typed in there. And then let's go ahead and type in 2x minus 3. Remember, the x button is directly below the mode. Okay, arrow down to y2 and type in the second one, which was x minus 1. All right, now you can just press the graph button, but again, as we start doing more stuff with the graphing calculator, sometimes we'll be zoomed in or zoomed out or something. So if you press graph and you don't see a good picture, remember that zoom 6, zoom standard, will always get you this kind of window, a -10 to positive 10, -10 to positive 10 on the axes. So zoom 6 always kind of resets your picture for you. All right, now sometimes you can look and say, oh, I can see where they cross visually. Other times you can't. So our solution sometimes will end up being a decimal, and our calculator is useful to help us find that. So if you look on the steps that we see here, so put equation 1 into y1, equation 2 into y2, zoom. All right, step 5 says to press second trace. So you'll see right above the trace button it says calculate. This is allowing your calculator to calculate something for us. So we'll press second trace, and you have lots of options. We want to find where these two intersect. So we're going to choose option 5, either arrow down and hit enter, or just press the number 5. That's what these numbers are there, just as like a shortcut. All right, then the calculator is going to ask you several questions. It says first curve, question mark. It doesn't matter which one it's on, as long as whenever it says second curve, it will automatically jump. So you really just have to hit enter twice. First curve, just hit enter. The calculator will automatically jump to the second curve. Just hit enter. Then it'll say guess, and you do want to take your cursor and you want to get as close as you can to the intersection point. Doesn't have to be perfect, and hit enter. And it will give you your answer. You just have to put it as an ordered pair. So you can see that that matches up with what we got on question 1. All right. Now, the example that we're going to do with the multiple choice, first of all, I know most of you, if I gave you this question and it was multiple choice, you would probably take the answers and plug them in and figure out which one worked, which is a perfectly fine solution to a multiple choice question. Okay, but I want to try this one with our graphing calculator. So we do have to solve each of these for y in order to use our graphing calculator. So the first equation, I would have to subtract x. So I'll get 2y equals negative x minus 7. Then I have to divide everything by 2. And that would get me y equals, and if you want, you can think of this as, instead of negative x divided by 2, it could be negative 1/2 x minus 7/2. If you want to change that to 0.5 and 3.5, you can. Okay. So that's one of my equations. The second one, I need to solve this one for y also. Personally, I would probably add 3y to both sides, but I know most of you might not like that. So I won't. Okay, I'm seeing face. We'll subtract 2x. So we have negative 3y equals negative 2x plus 0, or 0 minus 0. Then we'll divide by negative 3. The two negatives will divide out to become a positive. So this would be y equals 2/3 x. That's my second equation. Now we go to the graphing calculator, and we're going to type those in. So go to our y equals. And in the calculator, you can obviously put in negative 0.5, but if you want to put in the fraction, you would do parentheses. Now, be careful. Someone will have this problem. This is the negative key. This is the minus key. When we write them on our paper, it's interchangeable. In the calculator, it's not. So you'll notice that the negative is a little bit shorter than the minus key. So make sure that whenever you're using these, that you're using the correct one. So we do want negative 1/2. So that'd be negative 1 divided by 2, x. Now this is a minus 7/2. So I'll do a minus 7/2. Again, if you don't like that in your calculator, you're welcome to put 0.5 and 3.5. But I just like to show it in case this came out to be negative 1/3, you'd have to use the fraction. And then for this one, you'd have to put in the fraction, 2 divided by 3, and then x. You want to put the x after the parentheses. Again, we'll press zoom 6 to see our graph. Is anyone not seeing this graph? There's always a couple people that's calculating in trouble. Okay, where's your go grab one, so you can practice it. And then find the intersection if you haven't already, pressing second trace. Option 5 for intersect. Again, first curve and second curve are really kind of silly questions. The only reason your calculator asks you is eventually we'll graph like 5 lines. And if we want to find the intersection of just 2, you need to tell it which of the 2. So that's why it asks. I know right now it seems pointless. And then the guess We get as close as possible, and we should get -3, -2, which would be answer D. All right, the last thing we'll take a look at then are our special types of systems. So we have an independent system. Is one that has a unique solution, has an answer, one answer. For example, all the ones we've done so far were independent systems. They had one intersection point. And here's an example of that, again, where they cross at one point. The next one is a dependent system. And a dependent system is one that does not have a unique solution. Okay, it actually has infinitely many solutions because they are lines that are falling on top of each other. Okay. So it has infinitely many solutions. Every single point on the line is a solution because the lines are the same lines, a line on top of itself. And then the last one is called an inconsistent system. And an inconsistent system is when they have no solution because they never cross. And for them to not cross, they have to be parallel lines. I know in geometry we'd also talk about skew, but that would be in 3 dimensions. So in 2 dimensions, the only type of lines that don't intersect are parallel. So you can notice if they're going to be an independent system, they're going to have different slopes. They're not necessarily opposite reciprocals because they don't have to be perpendicular. They just have to be different slopes. The coinciding lines, it's a line on top of a line. So these are going to have the same exact slope and the same y-intercept because they are the same exact line. So y equals 2x plus 1, y equals 2x plus 1, line on top of itself. And then the last set, which is our inconsistent system, those are going to have the same slope, but they're going to have different y-intercepts. So you can determine what type of system you have just by looking at the equations and observing their slopes or their y-intercepts. So the last 3 questions ask us to classify each system as inconsistent, independent, or dependent without graphing them. Okay, so without graphing them, you're going to solve each for y and observe the slope and y-intercept. So for the first one, this one is already solved for y. For the next one, I'll have to add 2x to both sides to get y equals 2x plus 1. And then I can see that these have the same slope, but they'd have different y-intercepts, which means they would be parallel lines, which tells me that this is an inconsistent. Sometimes they'll also ask you to name how many solutions. This one would have no solutions. See if you guys can try B and C while I'm passing out your homework. All right, who can tell me what we got for B? Was it independent, dependent, or inconsistent? Garrett? Independent. Let's take a look. We should get y equals -3x plus 5. And whenever we subtract 15x, and we divide by 5, and we'll get y equals -3x plus 2/5. So this one would not be independent because the slopes are actually exactly the same. So if the slopes are the same, we then check the y-intercepts. The y-intercepts are different. So this one should be inconsistent. Make sure you don't just look at the number in front of the x. You have to solve for y first and then look at your slopes. How about the last one? Lexi? Independent. Which I'm shocked I didn't put one of each kind, but I didn't. So it should be independent. This one we will get y equals x minus 5. And y equals 2x minus 3. Different slopes, therefore independent. All right, your homework then is the 3.1 worksheet. You are solving by graphing on all of them. If you want to use your graphing calculator to check them, you can. But I still want you practicing by hand.